Okay, so we just talked about how to calculate pulse pressure. Now I want to talk about a second measure that we can use to quantify blood pressure in the arteries. That quantity is mean arterial pressure, or MAP. Okay, before I talk about how to calculate it, I want to talk about kind of what it represents. Okay, so it sort of represents an average blood pressure in the arteries. Okay, so we talked about how there's a systolic pressure and a diastolic pressure. MAP gives you just one number that you can use to characterize the blood pressure in the arteries. Okay, this is how you calculate MAP. So these are mathematically equivalent. You can calculate MAP as diastolic pressure plus 1/3 of pulse pressure, or you can calculate it as 2/3 diastolic pressure plus 1/3 systolic pressure. And I just want to point out that the reason it's not a simple arithmetic mean, the reason we don't just take systolic pressure and diastolic pressure and just average those, is that we spend about 2/3 of the cardiac cycle in diastole, ventricular diastole, and about 1/3 in ventricular systole. And that's why we calculate MAP as 2/3 diastolic pressure plus 1/3 systolic pressure. Okay. All right, so now I have a task for you to do. I would like you to see if you can calculate MAP in this example. So go ahead, hit pause, do that, and we will come back together and go over the calculation. Okay, let's calculate MAP. So I'm going to just start by saying that MAP was 93.3 millimeters of mercury. So if you were able to calculate this on your own, then it's not necessary for you to watch me do this calculation, but you may if you are interested in doing so. Okay, so we are going to start by calculating MAP using this method right here. Okay, so MAP is equal to diastolic pressure plus 1/3 pulse pressure. Our diastolic pressure is 80 millimeters of mercury. Our pulse pressure, we know from the previous slide, was 40 millimeters of mercury. So that's going to give us 80 millimeters of mercury plus 13.3 millimeters of mercury, which comes out to 93.3 millimeters of mercury. Okay, now let's calculate MAP using our other method, which is this formula right here. MAP is equal to 2/3 diastolic pressure plus 1/3 systolic pressure. So our diastolic pressure is 80 millimeters of mercury. Our systolic pressure is 120 millimeters of mercury. So we just plug those into the equation, okay? So that comes out to 53.3 millimeters of mercury plus 40 millimeters of mercury, which gives us 93.3 millimeters of mercury for our MAP. Okay, so we just went over how to calculate mean arterial pressure, or MAP. Now I want to talk about the factors that affect MAP. Okay, so I want to start by saying basically that the pressure the pressure in the arteries is going to reflect the volume of fluid that we have in our arteries, or the volume of blood, right? So the more blood we have in the arteries, the more we're going to be pushing against the artery walls, and the higher our pressure will be. Okay, that volume in turn is affected by how much blood is coming into the arteries from the heart and how much is exiting the arteries through the arterioles. Okay, so I would like you now to ponder these questions here. How do you think cardiac output is going to affect MAP? And how do you think arteriolar resistance is going to affect MAP? So if cardiac output goes up, if arteriolar resistance goes up, what is the effect going to be on MAP? So take a moment to think about that. Okay, so hopefully you came to the conclusion that cardiac output is going to be positively correlated to MAP. So as we increase our cardiac output, we're going to increase our mean arterial pressure. So if you think about it, more cardiac output, right? More blood coming out of the heart. That means more blood volume in the arteries. That means more blood pushing on the walls of the arteries. And that means an increase in pressure in the arteries. Arteriolar resistance. Hopefully you figured out also that as arteriolar resistance goes up, MAP is also going to go up. Okay, so the higher our arteriolar resistance is, the harder it is going to be for the blood to leave the arteries. Okay, so that means our volume of blood in the arteries is going to go up, and again, that's going to increase the pressure of the blood pushing on the artery walls. Okay, so we have this mathematical relationship that describes how cardiac output and arteriolar resistance affect MAP. I don't expect you to know this or have this memorized, but I do want you to understand this relationship sort of conceptually, okay? Okay, let's talk about a couple more factors that affect mean arterial pressure. One of those factors is the volume of blood, so our total blood volume in our bodies, okay? So as you might imagine, the higher our blood volume overall, the higher our MAP is going to be, right? Because again, more blood pushing against those walls is going to give you a higher pressure. Our blood volume is going to be affected by urination and drinking, right? So if you pee a lot, your blood volume is going to go down. If you drink a lot, your blood volume is going to go up. And that will make more sense as we later on when we study the kidneys, okay? Another thing that's going to affect MAP is the distribution of the blood in the circulation, right? So again, MAP stands for mean arterial pressure, which represents the pressure in the arteries, okay? So if we have a bunch of blood in the arteries, if we move blood to our arteries, that is going to increase MAP, right? So I do want to point out, usually our arteries hold about 11% of our total blood volume. As I mentioned before, our veins hold about 60% of our total blood volume. So if our blood pressure goes down, if our arterial pressure goes down, we can compensate for that by increasing our venous return so that we can then shift that blood from our veins to our arteries, so that we can compensate for that loss of blood pressure.